Okay, hello everyone. Today, let me briefly explain the basic concept of database design. Okay, let me first explain the relational model. Many people, many students do not understand the meaning of the definition of relational model. So let me explain why we need the relational model. So basically, the reason we use the database is to store some data. So to store some data, we usually find some important concepts called entities. For instance, if we consider SKKU management system, we need to store the information on students, courses, and professors. So to store the information on those data, we need to use the database systems. And when we store these data, we also need to store some relationship between two entities called relationships. It means that we also need to store the information on students take courses, professors teaches courses. Here, some students take some courses, and some professor teaches courses. We also need to store this information. The relationship is some interactive information between two entities. So we store the entity information as well as relationship information in our database. And now the question is, how to store these data? Basically, we can consider the flat database. The meaning of flat file database is that we just store the data as a single table. So this is our information for the students, courses, and professors. We can just store those data into one single table. And here SID is our ID for student ID, and name is our student name, and course name is our title for courses, and CID is course ID. We just store those data into one table. So when we store this data into one table, it's really good for it's easy to use and simple to create this table. And creating this table is not expensive. But the key disadvantage of using the single table is it incurs data redundancy and inconsistency. Here, the meaning of data redundancy is that some data are redundant. Here, the Alice appears 3 times in 3 rows, and Bob also appears 2 rows. And this phenomenon also happens in course name. As you can see, the data structures appears twice, and database also appears twice. This is a problem of data redundancy. So if we want to update this one single table, it means that we want to change the course name, we want to change the name of data structure as Introduction to Database Structures. We have to change multiple rows at the same time. In that case, if we only update one row, we just change this row as Introduction to Database Structures, Introduction to Data Structures. They have some inconsistency. So if we want to update the same information, we have to update at the same time, but this is not easy. So it is really bit difficult to maintain for redundant data. So to address this problem, one possible solution is we just split one table into multiple relations. Here, based on the relation student takes courses, we just split one table into 3 relations. Actually, the meaning of relation is similar to tables, but formally we define this as relations. Some students, I guess most of us students don't know how can we split one table into 3 tables. Let me further explain how we split that. So this is a one single table, and we know the relationship. The student takes courses, and based on that relationship, we can split one table into 2 relations. Here, this relation only stored student information, and based on student information, we can also store another relation. And they share SID. So if we match these SID, we can reconstruct these 2 relations into one relation. Similarly, we can further split this relation into 2 relations. Here, they share CID, course ID, so they share the CID. So based on this CID, we can also reconstruct the existing table. But as you can see, this one single relation include some redundant data, right? Alice, Bob, data structures, database. But once we split one relation into multiple relations, they don't share any redundant data. That's why we split one relation into multiple relations. They do not share any information. Actually, the node shares some SID, but this is a minimal redundancy. Based on SID, we can combine 2 relations. Without using SID, we cannot reconstruct the previous relation. That's why this is a minimum redundant data, and this is also similar for CID. Okay, so based on this operation, we can finally get 3 different relations. Here, the relational database, the meaning of relational database is that a database consists of multiple relations. Each table, actually, as I said, the relations are similar to tables, but they are a little bit different. So next time, let me explain the difference between relation and table. But for simplicity, you can just consider relations as table. So usually, the relational database consists of multiple tables, multiple relations. This is for relation. This is the relation for student. This is the relation for node. This is the relation for courses. By using different multiple relations, we can avoid data redundancy. So if we need to update some information for courses or students, this updated data doesn't affect other relations. So we can, it is good for supporting data consistency. And if some user try to access courses, other user also try to access students at the same time. So you can also efficient for sharing data. But the problem is that because we split one relation into multiple relations, it is more complex, and sometimes we need to combine 2 relations to retrieve some data. In that case, we need more time latency. It means that if we want to find some students who take some courses whose CID is 2 or 1. In that case, we have to combine two relations. So when we use the one single relation, we can directly find some information. But after splitting multiple relations, we need to combine. We need to combine two relations. Let me show you how to combine multiple relations. If we want to combine student and enrolled, we can just use, based on the SID, we can generate another virtual relation. Actually, this relation doesn't exist, but by using student and enrolled, we can generate one new relation. So based on this relation, we can find some information. At least, such as for Alice, we can find some students who take the CID 201. Here, Alice and Bob. We can find out this information based on this combined relation. We can further combine this relation into another relation, and finally, we can reconstruct the original relation. And based on this original relation, we can finally retrieve some related information. But in the physical layer, we only store students, enrolled, and courses. So if we want to find some information, we need to combine these three relations. That's why we need more time latency. So, and this combination is called join operator. So we are going to study how we join multiple tables. So if you feel difficult to understand, it's okay. We are going to study the join operator later. It's okay. You just understand the concept of relations and why we split, why we need to store the multiple relations without using a single relation. It's okay. And now let me explain the database design. Let me explain the database design. This is the overall structure. Given a mini world, we can model the mini world and we can describe the ER diagram. The ER diagram consists of entities and relationships. For instance, entity is a student courses, and relationship is that the students take courses. This is a relationship. For entity and relationships, we can design the ER diagram as a conceptual DB model. Once we design ER diagram, we can transform ER diagram into relational model. Each row is represented by relations, and there is some arrow. This is a relationship between some relation. You don't need to know the details, but you just understand the overall flow of database design. So based on the conceptual model, we can generate the logical model, which is called relational model. And finally, this logical model is stored in database. This is the overall procedure of database design. So in this course, we are going to study the conceptual data model as ER diagram, and we will study relational model as logical model. So you don't need to understand the details for ER diagram and relational model. Okay. So let me more explain the overall procedure of database design. This is a real world, and we first analyze the requirement for the user requirement. And based on the user requirement, we can generate the conceptual DB design. Here we can use the ER model, entity relationship model. After that, we can transform the conceptual design into logical design. Here, we can use the relational model. And once we design the relational model, we can store the relational model into physical way. Here, we can use the file to store the relation. We can use the file, and we may also need use indexing. This is the overall structure. For each design, we use different data model. Okay, and here the conceptual from the real world analysis to conceptual design. This is independent of DBMS, so we can just use the ER model without considering the specific DBMS. But if we consider relational model or physical design, we have to determine what DBMS use. Usually we use the relational DBMS, so based on the specific relational DBMS, we can design the logical design. We can use the logical design as the relational model, and we can also use the physical design as some indexing structure. Okay. And now let me further explain the relational data model is. The data model is a collection of high-level concepts to describe the data. This is a conceptual data design. So in the relational data model, we usually represent the data as tables, relations. And based on several relations, we can represent the data. And here, to represent the relation, we use the schema. This is a description of data using given data model. Okay. So the relational database consists of a set of relations. This is one example of relations. And here the schema is relation name and name of type for each column. Here CID, name, credit, department, this is a schema. In the schema, we do not store the specific data. An instance is a table with specific data. Here, this is an instance. For each, this is an instance. And number of rows is called cardinality, and number of field is called degree, or columns. Number of columns. Okay, and in our instance, each row is called tuples. Okay, so you need to understand the concept of schema, instance, and tuples. And so let me further explain the relational data model. And as I said, the relational data model is a logical database design. So we can represent the logical schema as like this. This is a student schema, student relation, and student relation consists of three different data types, and SID, name, and GPA. Each column, the data type of each column is string, and float. And for courses, this is another relation, and we also specify three different columns: CID, name, and credit, and their data types are string, and integer. And you can also specify another relation in Node, and it also consists of three different columns: SID, CID, grade. Actually, this example is a little bit different from previous example, but you don't need to consider the different meanings. In this example, we just specify three different relations. And once we define three different relations, this is for each relation. This is a schema. The student schema is SID, name, and GPA. The schema for courses, it consists of CID, name, and credit. Similarly, the schema for Inode is SID, CID, grade, and grade. and these are instances for different relations, and as I said, each row is called tuple. And now we can specify some relationship between different relations. The arrow means that the inode refers to students, and inode also refers to courses. Here, the SID in inode refers to SID in students, and CID in inode refers to CID in courses. To represent the references, we just use the arrows. Okay, based on that arrows, we know that the anode SID is based on SID in students, and CID in inode is based on CID in courses. And based on these references, we can combine multiple tables if we need. So next time, let me explain how we combine two or more tables, more relations. Okay, you just understand the concept. It's okay to understand the relational data, what relational model is, how we represent the relations between multiple tables, multiple relations. And now let me explain the SQL. SQL is a specialized language for database systems. So SQL is known as structured query language. So using SQL, you can efficiently access the data for DBMS. So if you want to interest in studying SQL by yourself, you try to access this link, and you can find some detailed information about SQL. Okay, there is a grammar for SQL. There is a SQL tutorial, so you know that. Actually, this is an example of SQL. This is really easy to understand without studying SQL. The meaning of this query is that you want to find some information. From customers, and select means that you want to retrieve everything. Star means everything. So this query means that you want to find all customer information. Easy to use, right? And there is some exercise. You can find some exercise and other syntax and other grammars and keyword. Other keyword used in SQL. This is to use. Okay, little bit. Yeah, you can just try to study. And there is a quiz. So if you, after studying this SQL, you can also try to solve the quiz problem. Okay. Okay, so to use the DBMS, you have to use the SQL. But as I said several times, it is not easy to use. You can easily study SQL. Okay. So to use DBMS, you have to understand SQL. Okay. We also, in our class, we also cover how we use SQL. Okay. And so using this SQL, you can generate some queries. Here, the meaning of query is you want to access some data from your database, and you also formulate the result of request. So for instance, if we want to, this is an example of queries. What is the name of the student who's with SID 100? In that case, using the SQL, you can just write down your statement, your SQL statement. So you can also specify some SQL to find how many students are enrolled in CID 301. This is a typical examples of queries. But to find some data, you can just specify SQL. Okay, and when you find some data, you may need to combine two or more relations. Okay, as I said, this is called join operator. So based on the join operator, we can access multiple relations. Okay, so let me further explain the database design process. This is a conceptual data model, and based on the conceptual data model, we can generate the relational model. And when we generate the relational data model, we also need to specify constraints. And sometimes we further split one table into multiple tables to eliminate some anomaly problems. It means that some data has redundancy. In that case, to eliminate the data redundancy, we can further split one relation into multiple relations. We call this procedure normalization. So we also cover how we split one relation into multiple relations by using normalization theory. Okay, this is a more detailed database design process. And finally, we can split the overall database systems into multiple different levels of schema. Okay. For the users, we can use the external schema. This external schema is also called views, and by using the views, we can access the database. But here, the external schema can be different from the conceptual or physical schema. It means that users can access different schema. This is because of data privacy or other reasons. But independent of conceptual or physical schema, we can generate the external schema. This is also similar for conceptual schema. For the conceptual or logical schema, we can just design multiple relations, and based on multiple relations, we can store the data into the database. And to store the data to database, we need to use another schema called physical schema. And this physical schema is also independent of conceptual schema. It means that each level is independent. So based on this independence, we can generate different schema, and we can try to communicate with different schema. This is another reason of why we use the DBMS. By using DBMS, they can support the independence for each different schema, each different level. Okay, that's the cool thing of DBMS. Okay, so far I explained the basic concept of database design, and I briefly explained the concept of relational data model. So next class we are going to study the relational data model in more detail, so you can just understand the brief concept of relational data model and database design for each chapter. So before the midterm exam, we are going to cover each topic in more detail. Thank you for listening. Thank you.